Hi guys, so I'm recording this video on for DMAOT for the portfolio sum. So I'll be recording these videos as and when I get a time. Today we have a DM exam. After that I'll do that. I've also asked some other people to help out. So hopefully before the exam we'll have most of the videos ready. Okay, so let's start with this sum. So this was done yesterday. We told ma'am that this is an easy sum, so if she can give this in the exam. Mostly what will happen is the data will be given of four random stocks, and you have to find a portfolio, create a portfolio with the lowest Sharpe ratio or the highest return or the lowest risk, whatever. Now, first thing that you need to do is to create a uh, named range. So how do you create a name range? For those who were not in class yesterday, so you can just select the entire data, Control Shift down, and then give it a name. Let's say this is stock one, or here in class we did it as Tata. So because Tata is already named in my worksheet, so that's why I'm giving it stock one. So click on that, select the entire range, name it stock one, and click on enter. Sorry. So this has to be named. Let's just stock one. Okay. Now what will happen is if you reference it to equal to stock one, so you can see this stock one is coming. So you can name it Tata, you can name it whatever, that based on the name of the stock. So do this for all the columns. So stock one, stock two, stock three, stock four. Okay. Or you can name it Tata, Bajaj, SBI, HDFC. Correct. The first thing is this: you create the name range. Second thing is creating a covariance matrix. So why we are creating a covariance matrix is because we need to calculate the Sharpe ratio, and the Sharpe ratio formula uh, that we were told yesterday. So basically, you don't need to know the formula. Just have this written down somewhere, this formula, so that you can actually calculate this easier, right? So you need basically the covariance. So it's the square root of weight one into variance one plus weight two into variance two, and so on. So because there's a crunch time, so that's why I don't want to waste explaining Sharpe ratio right now. Basically, it's the incremental return for every unit of risk that you take, right? So firstly, you have to create a covariance matrix. Now, covariance matrix is using this formula equal to covariance dot s. And so what you can do is covariance dot s. Ideally, we would have done, okay, let's say I'm doing Tata, comma Tata. So I would have done this entire column, comma, and then again this entire column, right? Now, because this is time consuming, what we are doing over here is instead of doing this, we have written the column, this is not the column header. So this Tata Motors return is not the column header. The column header is the named range. So you have named it as stock one, stock two. So similarly, let's say you have named it Tata, Bajaj, SBI, HDFC. What you can do is equal to covariance S. Now if you directly write Tata, what will happen is that will also work. If you write Tata, comma Tata, that will also work. But then you can't drag it across the entire table. So what you do is equal to covariance S indirect, then give the column header, comma row header, and close the bracket. Parenthesis is missing. Yeah, so uh, indirect this, comma indirect this. Okay, so now this is working. Now what you have to do and additionally is to create a dollar symbol on the header so that you can drag it. Otherwise what will happen is if you drag this, the next column will become I 4 comma uh, H5, and it will give you a reference error. So if you see, if I drag this, it'll give a reference error because your column and that is also shifting with how you're dragging it. So that's why what we do is here, when it comes to the column, all of these are in the same row. So you can see this is the fourth row. So that's why we want to fix 4. So as it moves, H will become I will become J will become K. But everywhere I need it to be 4. So that's why $4 over here. And when it comes to the column, I want it to be G. So it should be G5, G6, G7, G7. So that's why I'm fixing G. So G5, so put a dollar on G, the dollar G5. Now if you drag the formula across, it will work. Okay, so this is the second step. The third step is to calculate the average return. How do you calculate the average return? Again, you do average, and you can write Tata, or you can write indirect, and then this. Okay, so make sure always to, so there is no space or something. So if you write Tata comma space, it might pick up or might not pick up. So make sure it's the exact same thing that you named the columns. Okay, now this is the average daily return. In terms of weights, so this is the weight that I have assigned. um, so this is a default setting that you assign, and then you run solver and you'll get the actual weights. So you can write anything, but it should add up to one, right? um, so let me, yeah, so this should add up to one, and this is where we'll put the constraint of the solver, right? Now why have I made the weights in two, like weight in a column format as well as a row format? So this is because of matrix multiplication. So here you see that this is a 1 by 4 matrix, 1 by 4 because row into column. So this one row into 4 columns, and this is again 4 by 1, so 4 rows into one column. Now once you're done with this is the easy part done. Now there are three more formulas over here, right? The first formula is to calculate the daily return. How do you calculate the daily return? This is basically the daily return of each stock multiplied by the weight. Okay. Now, in terms of matrix multiplication, what you have to remember is you can multiply only a matrix that is. So this, let's take the example of this one. So this one, daily average daily return, is a 4 by 1 matrix. So it's a 4 by 1 matrix, and your weights are in these two formats. So you need a matrix that is and you need one row, so you need a matrix that is 1 by 4. So what happens is basically you multiply a 1 by 4 matrix in with a 4 by 1 matrix, and you get a 1 by 1 matrix. So what you do over here is basically, see, 1 by 4 matrix is this one, so I will multiply this with this. So if you see over here, you see I'm multiplying this with this. Okay. Now again, what I will do is annualize this. So this is the daily return. If I want to calculate the annual return, then it will become equal to daily into 252. If this, because there's a daily portfolio that is given. If it's a monthly or a whatever weekly, then if it's weekly, I'll multiply it by 52. If it's a monthly, I'll multiply it by 12. Okay. Variance is basically the matrix multiplication. So weight square into uh, your covariance. So that is the essence. So that's why we have to multiply weights twice. Again over here you can see that what we'll do is covariance matrix is a 4 by 4 matrix. So I will have to multiply a 1 by 4 with a 4 by 1. So if I multiply these two, I will get again a 4 by 1. So basically the one in the middle gets cut. So 4 and 4 get cut. So 4 and 1. So it will give a 4 and 1. And this 1 by 4 into 4 by 1 will again give you a 1 by 1. Right? So this is the important part. Rest of it is fine. So here what I'll do is firstly multiply the weight of height. So WH is basically, this is 1 by 4. Okay. Uh, sorry, this is 1 by 4 multiplied by 4 by 4, which is this one, and then multiplied by 4 by 1. So you see over here when the variance, it's this is the first one, then again matrix multiply the entire 4 by 4 grid multiplied by the 4 by 1 grid. This will give you the variance for daily variance. Now you have to analyze this by multiplying it by 252. This will give you the annual variance. Now for the standard deviation is simpler. It's just the square root of whatever variance you've got. So here you're getting a standard deviation of 26%. Sharpe ratio basically says that what is the incremental return over your uh, risk-free return. Risk-free return is basically any bond, mutual fund, or something which has a very low risk. Treasury bond, not mutual fund, any bond, government bond, anything which has a very low risk. Treasury bonds and stuff. So for the Sharpe ratio, the formula again, I'll just copy it over here. Copy is basically this actual return minus the risk-free return divided by your standard deviation. This will give you the Sharpe ratio. So basically, once this is done, so this is everything that is very important to do, and you can just note down the formulas and keep it with you. It's a anyways a open book kind of a exam, so you can have the formulas ready with you. This matrix is important. If you go get wrong with the matrix, then the answers might be different. So very important to note which matrix is to be multiplied by which matrix, right? Now, once this is done, there can be three possible questions that can come from this. So first question is go to solver. The first question, let's assume, is to maximize the return. So it can be a maximize the return considering that your standard deviation does not exceed, your risk does not exceed 30%. So for that, what will I do is basically I want to maximize my return. So this is the objective. So my return is over here. So I'll say that maximize this I23 maximize this by changing variable cells. These these are my variable cells. Add constraint should be that these. So basically this should be equal to 1. Okay. Um, you can add another constraint that each of these weights are greater than 0, but there's no greater formula. It's greater than equal to, so there's no point actually, because now because it's a portfolio is not a linear function, you have to use grg non-linear. And now if you solve it, you can see that solver found a solution, and the most maximum return considering, okay, so this is the maximum return that you can get is 109%. Now you can see the standard deviation is 54%, and I want that the standard deviation should not exceed 30%. So for that, what I will do is I'll add another um, constraint that this cell should be less than equal to 0.3, and click on add and click on OK. Okay. So you can see here I have added another. Sorry, I've added another constraint that is I25 should be less than equal to 0.3. Now, if I solve, this will give me an answer where my return will be lower, but the standard deviation is capped to 0.3%. Okay. This is the first question that they can give. You can be also asked a question where you should minimize the standard deviation. What you can do over here is then go to solver, select the subjective cell, which would be standard deviation in that case. Uh, Click on minimize, and by changing variable cells is same because you have to change the weight only. Rest everything is given. You can delete this one, which is just the constraint, and click on solve. It should already solve it, and you can see that it's saying that invest 100% in HDFC to get the minimum of 18% standard deviation. Now you can also have a question where it's the maximum Sharpe ratio. So for that, you can again go to solver, click on the objective cell as Sharpe, then click on maximize, changing variables is whatever. There's no other constraint I'm assuming, and click on solve again. And the maximized Sharpe ratio is 2.85 is the answer. So these are the possible questions that can come. uh, yeah, so I'll share the sheet with you also. um, I think the formulas written over here will help you. um, what you can do, if let's say this is the question, so you can create multiple copies. So if there are three questions, so question 1, question 2, question 3, what you can do is for question number 1, it says that let's say minimize the let's say maximize the sharp ratio. So you can write that this is the name the sheet as sharp maximization, right? Now create a copy of this, move or copy, create a copy, move to the end. And now let's say the second part of the question says you have to minimize the risk. So click on solver, change the click create minimize, uh, which value, this SD, and then click on solve, click on OK. So this answer that you'll get is the minimized standard deviation. So this is SD minimized. So you can create multiple sheets like this so that it's easier. Instead of doing it all over again, everything, even the solver values, uh, the solver constant and everything gets copied, so it's easier. And you can create multiple sheets like this, and you can write it question number 1, question number 2, whatever. Okay, just click here and click on move or copy, click on create a copy and then create. Okay, so I'll share this with you, and hopefully this helps. And when I get time, I'll record more videos. In the meantime, if anyone else wants to join in and make more videos, please feel free to do that so that it helps out. Thank you.